These documents I shared with you, that I've just shared online as well. I've also shared this with you on the Telegram. It's what we're going to use as an assignment, and I'm going to use that to teach you now to an extent, but the only 2 hours that we have today is not sufficient to finish everything. But I'll just see if I can answer one or two of those questions, and then I will leave you with the rest to go and repeat the same and submit it as an assignment, which should be in on or before this time next week. You only have 1 week to do the assignment. So, and it's very simple. All you need to do is to go and get SPSS installed on your system, and you undo it by yourself. So what we are just want to examine, if you look at this, this is like talking about a PhD thesis, for example, a PhD title. We want to examine factors influencing academic performance among university students, which is an illustrative quantitative data analysis using a simulated data set. That's what I want to do. That's what we want to do, just to demonstrate that if you have a question of this nature, or maybe a title of this nature, and you have some questions that goes along with that, this is the way to approach it quantitatively. Ordinarily, you can, if data sets are available to you in the public, you can also harvest them and analyze them. It is not all the time that you are required or that you be requested to go to the field and collect data. There are some data that have been collected and are made available on different platforms for research, for your use. So if your work intends to use secondary data, then you have them everywhere. And then wherever you are getting that your data set, depending on what you want to work on, you must ensure that you let people know, oh, this is where the source of your data is. Maybe it is from Nigeria Bureau of Statistics, or from World Bank, or from Cargo, and all of that. You have to let them know where you have retrieved your data. Unfortunately, most of these databases, most of these outlets make their data available for free, publicly available for free. So once you have downloaded that, you are good to go. So after you have downloaded that, how do you then begin to analyze your data set is what we want to talk about today. Most of the time, most of these data sets are available in CSV, in Excel format, or converted to comma-separated file. Because CSV is a format that is acceptable by so many platforms, so many applications. That's why most of the time they make it available in CSV, such that if you are taking it to R, taking it to Python, SPSS, Stata, to be ready to go there and to be accepted by those platforms. Now, let's look at this background. So the data set we are going to use, I've also forwarded to you, you have that already, is an hypothetical data set. It's not coming from anywhere. I generated it. But then there are a number of variables that it has. I'm going to show us now, after now, and they'll begin to talk about it. If you look at the background, we want to examine academic performance of students in the university. Academic performance remains one of the most widely studied outcomes in educational research because it affects the extent to which students achieve the expected learning outcomes of an educational program. So most of the time, somebody would think that for a student to perform well, if that student commits so much number of hours to what he or she is doing, there's a likelihood that the student will do well. If you look at literature, there are some literature that will support that. Fine. There's some people who will say that, it depends on the financial status of that student. If the student is buoyant enough, there's a likelihood that he will perform well in the examination. Others also believe that, you find all of this in literature, that even if a student has access to ICT, computer, the internet, there's a likelihood that it will facilitate the way students, attend to his or her academics. But these are postulations. We are not sure about all of these assertions. But you now want to conduct a study to confirm whether age, gender, place of residence, where they are living, whether their marital status, because it's also possible for somebody who has twins. If somebody is on a PhD and you just put to bed, you have twins, and do you want to say that person will perform better than a single who is not married? So ordinarily, by face value, we want to say that if somebody is married and has responsibilities, there's a likelihood that that person may perform lower than another person who is not married. Those are assertions. But in the context of the environment where you want to work, you need to confirm. You may have seen all of this in literature. This is the way you are expected to, that is some of the things that you expect to be reporting in your literature when you are writing it, relating to this title. You have to compare so many empirical literature, what has happened in the United States, what is the state in developed countries and undeveloping countries, in Africa, in South Africa, in Ghana, and what is happening in Nigeria regarding that particular thing you're working on. So you will have been equipped from literature, some of those things that you have seen, that you have read, as it relates to this, as is in operation in different places, because location also may make things to be different. Make things to be. So what is happening here in Nigeria may not necessarily be replicated elsewhere outside Nigeria. And that's the purpose of conducting research. So we now want to use this data set now, which I'm going to show you to follow the process. And the steps, I've already highlighted the steps. And I brought out also some hypothetical research questions, which may be in line as well. Now, there are a number of variables. There is what we call the dependent variable. There are independent variables, there are moderators variables, there are control variables, there are dummy variables, and a number of that. The dependent variable, just as the name implies, is depending on others to act or to behave. A dependent variable is also seen as your target variable. The variable you want to see what will be the performance when others impact it. It's called the dependent variable. So in this case now, our dependent variable is academic performance. Academic performance could also, we can also use the proxy of CGPA to represent academic performance. If we are talking about overall performance of students in the university, the CGPA is what we can use as proxy to represent academic performance. So we have also independent variables. Independent variables represent other variables that do not depend on others. They're only there to play their role, to play a part on dependent variable. They may have impact on the dependent variable. They may have small impact. They may have large impact. They may have negative impact. They may have positive impact. But as we speak, you cannot tell until you have subjected it to test. And that's what we want to do. So if you look at a list of independent variables that we have here, in the context of this work, in the context of that data set, we have the study hours, we have research skills, we have ICT usage, we have monthly income, education captured in years, and a number of other things. So we also have the moderator variable as well. So in this case, we want to check whether some other things can also influence the performance of students, can also influence the dependent variable. So we refer to such as a moderator variable. Some of them, among others, is motivation in the context of this work today. And the other one is control variables. Age could be a control. We want to check whether age also, whether if you are a male or a female, age rather, whether if you are young or old, can also affect the way students perform. We also want to check with gender, whether male students do better than female students in a particular subject, in a particular discipline, and all of that, or vice versa. We also want to check whether where they are living, because some of the time, where the residence of anybody, if, take for example now, if you want to conduct a research, and you are talking to the people in the house owners in Banana Island, you already know by our setting, or by our, what do I call it now, by our setup, if I may use that word, in Nigeria, we already know that it's only the rich that can have accommodation in Banana Island. When you are comparing somebody in Banana Land filling your questionnaire and another one living in Olumate in Ife here or Nyoforogi, it's enough to let you know that it's a different ballgame entirely, on the face value. And then another one is household size. How many people are there? When you have too many children, that's why most people don't give birth to too many children these days. During our father's days, they have 7, they have 10, 12, 14. I don't think a single family will have nothing more than 5. I even doubt 5. You can't even see 5. When you knock like 4 houses, you only can see 5 siblings together belonging to the same parents. So outsides at times may also have effect, because if the house is too large, there's a likelihood that the meager resources coming in will be sliced among them. And if you see a student who is supposed to be taking like maybe 100,000 per month when he's in the university, what is available to him is only 10,000 naira. There's no way now you can't be hungry and still be performing. So these are some of the things that research would like to test. We won't just assume that on the face value we can say yes, it's possible, but it may not be. So we want to see how some of these variables will affect the dependent variable. So we have set about 5 questions in this work. So I'm only going to treat like 2 or 3 of that. Yeah, I'm going to treat about 2 or 3 in this class as we go today. So let's quickly see, after you have downloaded your data set, which I have retrieved, I'm going to show us again you have to import it in SPSS. I decided to use SPSS because it's the easiest analytical tool you can work with, at least for now. It's the easiest analytical tool anybody can work with. Ordinarily, it's not hard to import. Let me see. All you just need to, this is the data set already in my SPSS, but it's not hard. Let me close this and open another one. Okay, let me just exit. And then let me now launch my SPSS. Once you launch your SPSS, I think I want to launch version, the IBM version. It should still be able to work for me. Okay, I have version 26. So you open your SPSS. I'm assuming that majority of us don't know it. That's why I'm trying to come from the beginning. I don't want to assume you all know it, because if I assume some of the people that may not know it will now be disadvantaged, and I don't want that to happen. So it's opening. All you need to do, you must have saved your file somewhere in a particular folder, which is what I have done, which is what I believe you must have done as well. So I will close this. Okay, I want to open a new data set. So you have a blank page like an Excel page. If you look at this place, you will see data view and then variable view. Why is this thing here? Okay, you see data view and variable view. Those are the two views that your SPSS will carry. In the data view is where you are going to be keying in all your data. If you are doing, what do we call it now? If you are into keying in your primary data sets. Now, and this is where the variable view is where you're going to be defining your variables. Okay, that's fine. So, but in this case now, we are not working with primary data set, but rather we are working with an existing data set that we have saved somewhere, that we have downloaded somewhere. So what you need to do is just go to your file, and click on open. Click on data. Then you now have to trace your data set. Most of the time, it will not open it by default. You have to specify that I only need star.csv files. Put it in the file name. That means it should only present files. You can see this one now that ends with CSV. So this is what I want to work with. I click here and I click on open. You wait for it to open. It will not open. It will bring a dialog box where it will ask you questions about the data sets. We are there. It's saying, welcome to Import Wizard. Does your text file match a predefined format? No. Most of the time, you leave every setting at default. But let me explain to you. You click on next. Now, the next one is say delimited. It's talking about the separations. Variables are delimited by a specific character, yes, which is comma. From one variable to the other, that's why we call it comma separated file. From one variable to the other, it is separated by comma. So that thing highlighted, delimited is correct. Then are variable names included at the top of your file? Yes, because we'll find out that if you have opened that file, you must have seen that some of those things are already labeled on top in the first column. They are labeled. Like the first one for, what do you call it? The ID, followed by the performance, followed by student number of hours, years of whatever, age, gender, and all of that. They're already labeled on top. So the system will understand that, oh, this is already labeled on top. When I'm reading the data into SPSS, I must keep the first line. Okay, he now says further that what is the decimal symbol? The decimal symbol is period. Because there are some countries that when they want to write 28.5, they write comma as the point. So it's now asking us that in your own case, what did you use? Is this 28.5 as dot or comma or period? In our own case, it's period. So let's move on. You click on next. As you click on next, you come here again. The first case of data begins on which line number? Line number 2. Because the first line or the first case is for the header. Okay, so you move on. How many cases do you want to import? Now, the system can see straight away that we have 1,000 cases. All of the cases is what I want to retrieve. But in case you only need a few out of those cases, all you need to do is to just specify the number here. Click on the first number. You put maybe the first 100. But in this case, we want everything altogether. Or you want to just say, just sample a random percentage, irrespective of the number, not necessarily picking it from the beginning. Or just say just 10% of 1,000, which is 100. That's not what you want to do. I want all the cases to be retrieved. Okay, you just click on next. And it's saying now which delimiter appears between variables. We have said that it is comma, highlighted already. Leave it as it is. What is the test qualifier? None. Just click on next. And you are good to go. You say the variable ID name is this, and it's automatic. Just say next. Just say finish as well again to save your time. And before you know it, your data set is there. It's there. So let's go back and see from the variable view, from the data view. This is your data set. This is what you are looking at in the Excel. That's if you have opened it. This is it here. And then this is the variable view here. The variable view is where you will get the description of your variables. That, oh, this is age, this is gender, this is residence. Some people may not even use all of these fascinating words. It could be just Q1, H1, A1, all of that. But the label will give you the real meaning of what that variable is. So when you get here by yourself, you can prefer to say, okay, let me give it a label, gender, and all of that. You can do all of that if you want again. And then it's also important for us to say, after you have done all of this, another thing you have to do is to ensure that you define your age. Age is captured in words. If you look at the measures, you remember we talked about this in a previous class with me, where I was talking about nominal, ordinal, and all of that, scale and all of that. So this is where those things are useful. So age was captured by scale because they just want to supply the number there and they will go. But gender is whether you are a male or female. You still the same as nominal. It is not in any particular order. It is not big or another. So you just say nominal. Same for residence, nominal. Same for marital status is nominal. Now, if you now look at monthly income is usually in figures. You put scale and all of that, and so on and so forth. So, but ordinarily, okay, and so on and so forth. So that is that here. But at the same time, we also need to configure the missing number. But in this case, we're not going to configure that because of our time. I'm only going to speak about the value. The value here, this one. The value. For each of those variables, they have to be defined. Our ID, don't worry about ID. Age is going to be captured, just they're going to supply the number. You don't have to do anything, just leave it. Gender, gender will either have male or female. You click here to specify that. Maybe 1 is for our male. You click add. Oh, sorry. It's for male. Male. You click add. Maybe 2 is for what? It's for female. You click add and you say okay. By the time you come here, you can see that it has changed. Residence. Let us see the way it has been captured. I think I have the summary somewhere. Residence, it can be maybe rural or urban. Yes, I have this here. Residence. I kept it some. Yeah. Look at residence. 1 can be urban, 2 can be rural. So go there and say residence, you click here. 1 urban. What this is saying is wherever you see 1, that means it's urban. Wherever you see 2, that means that person has indicated that he's living in the rural area. So if I go back to my data view now to see for those 2 variables before I continue, the gender, you will see here now that our gender rather than 0, 1, and all of that we used to have before I change this. If you check your own, you will see that your own has not changed to male and female. It is only what you will see there is 1, 2, 1, 1, 1, 1, 2, 2, and all of that. So I can also toggle this one as well to switch between that number again. You can see that number there again now. But because we have coded this, when I click on this 8 to 1 and all of that, I can see. You can see the residence as well. It has changed to urban, rural. So we come here again, 1, 1, 1, 1, all of that. But we have represented it in the definition of the variable view as 1 for urban and other. So marital status as well. We can also have a number of things for marital status. Okay, we can have somebody can be single, can be married, can be divorced, can be widowed. So we are going to configure that as well. Single, married, divorced, widowed. Okay, so marital status. You click on value. 1 for single. You add. 2 for what? Married. 3 for divorced. The reason why I'm taking pain to do all of this is because I want you to be able to do your analysis by yourself. Don't give it out. It's not hard. You understand your work better. And the whole of the things that they are doing is not more than this. That's why I'm taking you through all of this. Number 4 is widowed. 4, widowed. Widowed. Okay. You add and you, okay. That is that. Now, let's move further again. What next? We have the residence. Okay, we have done that. Internet access, employment. Okay, internet access, whether they have internet access or not. Okay, internet access here. 0 for no access. You add that. 1 for access. For yes. Okay, what else again? Employment status. Unemployed, part-time, full-time, self-employed. Employment status. Unemployed, part-time, full-time, self-employed. Okay, by the time you okay and you go back to your data view, you will see that everything is already represented now here again. And that's what we're talking about. You can also toggle it. That's what we're talking about. So you can save your work so that save it. Still save it as what did I call it? Okay, this is new now. So you save that. Now let's now begin our operations. Now that we are ready now with the setup. All we need to do now is to begin to answer those questions. The first research question wants to know what are the levels of academic performance, study hours, research skills, ICT usage, motivation, and monthly income. They're only asking for level. They're not asking for impact. Whether one impact the other, no. These are just standalone. And if you see a question of this nature, the way to respond to this is to use descriptive statistics alone and not inferential. Inferential in this instance is not relevant. And how do you go about it? I've already specified. You go to analyze descriptives, and you report, you click on mean, standard deviation, minimum, maximum, and that is what you have to do. Now, what are the variables that we need? They are there: academic performance, study hours, research skills, ICT usage, motivation, and monthly income. So I will come in here and click on analyze. Look for descriptive statistics. Click on, after descriptive, you click descriptives as well again. Once you are there, what are the variables of interest? We are going to go to age, gender, residence, household. Age, gender, you can click your control down to be selecting them. Residence, household size, marital status, household size, and what is again? Unemployment status. I clicked on control while I was clicking those variables. You can click them one by one and I'll bring them here. You can also click them together. Excuse me. So once you are done with that, you now have to come to these options to pick the options of the output you expect. So here you check mean, you want the mean, you want standard deviation because you cannot compute mean without corresponding standard deviation. It's always good. They go together. Then compute the minimum and the maximum. The rest is okay for now. Ordinarily, the kurtosis, and the skewness are also parts of some of the things you need to check whether your variable is normal. It's a normal variable, normal indicator. But in this case, for just to check the level, we don't need to do all of that. So you now click on continue and you OK it. This will take us to the output view. This will bring us to the output view where you can see the syntax. These are the syntax that are made up of that, of what we have just done. But we don't need the syntax. But the syntax must go along with it because your supervisor may want to copy this syntax and run it. Because there's a way to run this syntax to confirm that indeed you have computed it. It's not that you just do an arbitrary table from somewhere. You know, there are ways, it is the syntax that will reveal that. There are some, even when you are submitting for some journal outlets as well, there are some that will request for the syntax. So this is the syntax here. But today I'm not talking about the syntax. I'm going straight away to the output, which is just this table. Ordinarily, people will copy this table, can copy like this, go to Microsoft Word, paste it, and report. But most of the time, it's good. That's the starting point. When you get there, there are standard formats for APA. That is upper seventh. What upper seventh will require is not what we have here. The lines for upper seven, line on top, below, and the last one. Those are the 3 lines upper will be requesting from you, which you can easily change when you get to your Microsoft Word. But this is not the time to also teach you how to do that. But what is important, the nitty-gritty there is what I'm particular about today. You can see that the variables are already generated. We have the age, the number that we treated, which is the n, is 1000 for everything. The minimum age, as found on our data set, is 22. The maximum age is 65. So from there, you can easily see that the age range is between 22 to 65. And what is the mean age? The mean age is already computed as 43.83 with a standard deviation of 12.56. Same goes for male. What do we have? We have the minimum 1, we have the maximum 2. That's fine, which means male and female. Okay, that's fine. We also have the residence. We have 1 and 2, which means we have done well. So some of the time, you also use this to check whether, because if you see anything like, for the gender, for example, if you see anything like 4, you see the minimum of 1 and the maximum of, you'll be like, what is happening? We have only defined 2 variables. Two classifications, male and female, 1 and 2. That's what I expect. So where is 4 coming from? From there, you can easily see whether there is any error in your computation. Then the marital status is also 1 to 4, which is what we have done. The household size is also 1 to 10. You can see the maximum number of children reported by your respondents is 10, and the minimum is 1. So it means there is nobody among these respondents that does not have 1 person recorded to be in the household. Okay. And then the employment status, we have 1 to 4. We have that as well. So that is what you need to respond to, what do you call it, to the first question, which is talking about the level. So from here, you can begin to report this table just like I've been explaining. So I will move on now to the next one, which is so from there, you can easily see that, okay, level of academic performance, I did not put it there. Academic performance should be there as well. Let me go and rerun it. I can go back to your data this way. I can go back to my this and include academic performance. The guy is there. It can be anywhere. If you like, you can take it up. I think, let me see whether I can move up. Okay, can move up. But irrespective of the, what do we call it, of the position, you will still have your variables. Okay, that's fine. So you can see this one is included. So rather than also using this table now, you can use this table now because this is the updated version. And we look at that, the minimum mark of the performance is 48, where the maximum is 100. So that means they have done it in percentage. The performance is measured in percentage. Maybe the average percentage for all of them. They have scaled it down rather than the CGPA. So in this case, what the academic performance used is not captured by CGPA. It's captured by percentage. Maybe in a particular subject. Maybe overall, in terms of the average in percentage, this weight has been captured with this data set. Ordinarily, any secondary data you want to download from anywhere they will have stated and defined their variables so that way you will know this is the way they have captured this one, this is the way they have captured that one, and all of that. So the variables, the explanation for the variables will also be part of what you will ship when you are doing the downloading of the data set. Okay, that's fine. So we have that the minimum academic performance is 48 here, the maximum is okay. What about the average mean? It means we have majority of them, not the majority. The average got 70.49. And the standard deviation is 8, which means 8 minus 70, that's the lower band, which will give us like 62, and then 70 plus 8, it means the lower band and the upper band, which is like the class interval, is between 62 and 78. That's what that standard deviation is talking about, in relation to mean. There are ways to report that as well, but you have to investigate that. That's part of your assignments because you are expected to put this table in your report to answer each of those research questions and then report what you see in the whatever. But your report must be based on APA 7th edition. That's why I posted a sample on our platform. Anything I post on the platform is not just for a joke, it's not just for any show off, but for you to take that advantage and take opportunity of whatever I'm posting on or even all the lecturers, whatever we are posting on the platform, it's for a purpose and for your benefit. Okay, that is that. Now that we are done with the first question, we now move to the second research question. So research question 2 is saying that what relationships exist among the study variables? What are the relationships that exist among the study variables? When you want to check relationship among study variables, what you need to do that is correlation. Because correlation will check relationship in terms of, are they friends? Are they close? Are they far apart? Is there a relationship? Is the relationship low? Is it moderate? Is it very high? Then is the relationship between one variable and others, is it negative or positive? Correlation will show you all of that. And that's why we have been guided now by the steps that what you have to do is to go to analyze, correlate, bivariate, and select Pearson correlation. And then we can see the strength, we can see the direction, and the significance. Okay, so you come in here to analyze, correlation, bivariate. And you can select all except the ID. Select all and remove the ID because you don't need the ID for anything. So this is what we're going to use to check the correlation. You can output it here and come in here. I selected all the variables because I want to see the relationship among all those variables we want to test. So yeah, ordinarily, I still always like to see the mean when I'm computing my correlation as well. Because I like a table. You can match the table of mean and standard deviation with your correlation. I always like that at a glance. It's usually very, very beautiful, you know. But you have to use AND to bring in all the, after you have separated you already have the output of your correlation. You have to now be picking the mean. Okay, let's see. We'll see what will happen. Okay, that's that. You can just click on continue and click on Pearson correlation and flag significant correlations. If you click on this, this will show you asterisk where those correlations are significant. If you don't click here, you will get your correlation, but your correlation will not be marked, will not be flagged, even when they are significant. But if you flag it, it will show you any of them that are significant. So here is our correlation table. And you can see this one is flagged star. You can use single star, you can use double star, you can see double star here. You can use single star here. Someone does not have any star. So those that does not have any star, it means they are not significant. But those with single star, it means they are significant at, you will see the definition down. You can see correlation is significant at the level of 0.005. That's 1 star. That's about 95% confidence interval. And you will see double star. It means correlation is significant at 0.001. That means 99% confidence interval, like we used to say, or 1% error level. You know, like I think I've taught you that in this class. So that's what that means. Now you have your correlation. But for correlation, you usually have the lower diagonal and the upper diagonal. Now you can see there is 111 here, unitary. 111 that divides those numbers, one for the upper and another one to the lower. Now you can pick any of the two. What that is still telling us is the same thing. So whether you pick upper diagonal or lower diagonal, you are still comparing age to age here. When you compare yourself to yourself, it is perfect. That's one. The next one, you pick age here, and you compare it to gender. That is where you have the correlation minus 0.066, and it's asterisk. It's significant. Now, when you compare this age as well with another one, residence, that's where you see negative 0.45. You know, and you can see the significance as well there, or also written in figures. You know, also written in figures. You can see that this 0.153 for residence is not less than 0.05. It's also not less than 0.01. That's why it's not flagged. But if you look at this age here, and you look at this age now, and you compare with gender, where it intersects gender, it shows that the significance to tail is 0.036, which means it's less than 0.05. So this means that this is significant at 95% confidence interval. So what that is telling us is very simple. It's very simple. Okay, they have just taken light now. I hope the internet will not switch off. Oh, it has come. Okay, I'm back now. It just took lights and I had to switch to empty. That's fine. So that's where we are. So what I'm saying in essence is it's not hard. I'm still talking about the correlation. Okay, let me see if someone has. Okay, so this is what you have. You just copy this out and go and address it in Microsoft Word to remove the upper diagonal and use the lower diagonal, and you clean it up. After you have cleaned it up, this is what you should expect. This is the kind of a thing, a correlation table that is expected in your work. This is my own output during my PhD. This is my own output. I've removed the upper diagonal, so I decided to use the lower diagonal. And I represented those variables because they may not contain, they may be too wide for each of those columns. So I decided to code them as Y is average sales turnover, X1 is this, X2 is this, and I put the legend here so that anybody reading that can easily understand. So that's the way it should be dressed. That's the way it should be computed. And that's the upper 7th version. Okay, so I move on. So that's we have now answered the second research question. Now, you now have to be interpreting it. We have done all of that. You have to be interpreting it. Like I said here, if you look at this, I'm comparing age and gender. Age has negative correlation. You can see with gender. Age is negatively correlated with gender. This is the correlation between age and gender, which shows that there is a negative 0.066 asterisk. It's telling us that this is the direction of this correlation is negative. And if you look at the strength of the figure of that value is far away from 1. You compare it to 1. This is 0.0666. So it's a weak correlation. There's a weak correlation between age and gender. There's a weak correlation between age and gender, and it also has a negative correlation. And with this situation, it shows that it is also significant because it is less than 0.005. You know? Then you can also look for under that age as well. Age and residence it also has negative correlation. Also has negative correlation. And then age and marital status also have negative correlation and also weak correlation. Negative, weak correlation, same for residence, same for education in years. So same for, but education in years is not negative, only that it's weak. But this also household size is also negative. So you can bring all of those negative and weak correlations together. You can report them together. That age has weak and negative correlation to or with gender, residence, marital status, household size, and if there's any other one, employment status as well. Also has weak and negative correlation. You know, internet access as well. Internet access as well. Yes, and all of that. So these are some of the things. But you can also pick. You can look at whichever. Let's see. You are still under that age. Let's see now. Is there any strong correlation anywhere? There's a strong correlation here with academic performance. This is 0.38, 0.638. This is a moderate correlation. We won't say strong because, well, I think it's strong. We can say it's slightly strong. Or let's say it's a moderate correlation, you know. If it is between 0 and 5 or less than 5, if it is less than 5, it is weak. If it is 5, I think between 5 and 6, we can say it is moderate or average, moderate, something like that. You can say strong correlation when it's 0.7 and above. So this is what I have here. You know, this one has a positive and strong correlation with age, has strong and positive correlation with academic performance, or academic performance has strong correlation with age. But in this case, and it's not significant because you look at the signal to tail, it is sorry, I'm misinterpreting it. It is the significance level that is 0.638. The correlation, the percent correlation is weak. It's 0.015. That one is weak. It's weak. And it's not significant because it's less than 0.05. It's weak. Is there any other strong one with age? There is no correlation that is strong with age. So I move to gender. If you go to gender, any strong correlation here to gender, I have not seen. I'm still looking at it. Employment, monthly income 0.0 is still weak. This is also 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 weak because it's not up to 1. So let me pick another one. Let's consider another one. Let's consider residence. Residence is also weak correlation with Marital status there. It's also weak here. 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 So which one is strong? The correlation of these things is very weak for majority of those outputs. It's weak for majority of them. Okay, anyway, you have to inspect it and check. Whatever you see is what you are going to report. You can't manipulate it. Whatever you see is what you should report. Okay, so I will leave that. I've already explained the threshold to you. If it is 0.50 points, you can say have a moderate correlation or moderate relationship. You won't repeat the word correlation again. It's moderate relationship. If it is 0.3, less than 0.5, you say it's weak correlation or weak relationship. If it is more than 0.6, that's strong relationship. That is that. Okay, so let me also move on to the next one. To the next, I think let's just do one more of those questions, and I'll release you with the rest. Research question number 3. This aspect is very important. That's the correlation. Do you know? It's asking a question about which factors significantly predict academic performance. We want to know. So that's what we call linear regression, simple linear regression. Simple linear regression is only when you are comparing one dependent variable and another independent variable together. That's simple linear regression. You know? So I'm going to do that one first before I answer this research question 3, so that it will not be difficult for you. I want to carry out a simple linear regression between, I'll go to regression here. After clicking on my analyze, go to regression, and I'll click on linear. After clicking on linear, we already know that our dependent variable is academic performance. I click here and I bring it under dependent. Now, my independent variable, I just want to pick anyone arbitrarily, but I think reasonably, let us check whether the use of internet can have effect on academic performance. If you like as well, you can also check research case, whether it has effect on academic performance. But in this case, I think I want to try internet usage because ordinarily that should assist students to perform well. That's what I'm just thinking. If that is what you are required to do, you do that. I just want to use it to demonstrate simple linear regression. Simple linear regression is between one variable, dependent variable, and one independent variable. So I bring that under here. I'm not going to do much here than to click on statistics and click on model fit. I want you to fit a model for me and do the estimates. Then I click on continue, and then you come to plot here as well. Plot, click on histogram so that we can see the normality plot. Normality instead of, in terms of to check whether the variable is normal. Those are some of the conditions of regression. Like I told you, before you carry out regression analysis, you are supposed to check for normality check, supposed to check for linearity, supposed to check for, what do you call it now, to ensure that there is no heteroscedasticity, which by now I know you must have seen from that video, has to do with varied standard deviation or variance. And even much more than that, there are a number of other things that you have to check out for. You have to ensure that there is no multicollinearity. Multicollinearity has to do with when the correlation is too much. It's when you have a good number of those variables that are representing themselves in terms of when you compare age and gender together. I said collinearity is when you compare one relationship between one variable and the other, and you notice that the relationship is not strong. It is expected for correlation. Relationship must not be strong. Relationship must exist, but must not be strong. In a situation whereby it is strong, we call it collinearity between one variable and the other. And that's why I'm so happy that the correlation table does not show strong correlation, which means our data set is ready. The data set is ready for regression analysis. But the converse is for factor analysis. When you want to do factor analysis, you have to also inspect that data set, your variables as well, using correlation. Relationship must exist among the variables. And relationship that will exist has to be moderate to strong relationship for factor analysis. In a situation whereby you have relationship less than 0.3 for factor analysis, you cannot use it. Okay, we don't have time to talk about that. I just dropped that in case you may meet it later in life as you go in your program. So we're only concerned with regression for now. Like I said, you only need weak correlation to be able to prevent against collinearity or multiple collinearity, which is called multicollinearity. Okay, I move on. So I click on histogram to be able to see the normality of the variable. So let's see it now. We just click OK. And this will give us the regression equation. So it will give you all of this. It will give you this. That regression output. It's saying that I have correlated dependent variable is academic performance with ICT usage. Now, the relationship is 0.22 here, which is the relationship between the predicted and the observed value. It's saying that the relationship is weak, which is understandable. That's what we want in this case. And then the R squared is the goodness of fit. Note that. The R squared, I must have mentioned in that previous video. That's why I say it's a prerequisite for this class. So time will not permit me to still be explaining that. The R squared is like to draw a line of fit around your data set. So this is showing the level of fitness to that data set. Or in the alternative, this is expressing the quantum of the proportion of the variation in academic performance explained by ICT usage. You know, this is explaining the proportion of the variation of the academic performance explained by ICT usage. So if you look at this in percentage, you multiply this by 100. 0.4 is multiplied by 100, which will give us 4.8%, which means this model that we have done, that we have computed, is only telling us that academic performance, the quantum of the academic performance is affected by, saying that the contribution of academic performance to academic performance, ICT usage to academic performance is only less than 5%. Which means there must be some other factors which are not considered in this model, which are germane for academic performance, which are not, you did not bring into this model. So in that instance, you cannot use that model to generalize or to speak for academic performance. That means it's not enough for you to now generate that model. That's this particular model, and begin to go all out and be telling people, I've seen it. This model is only ICT usage that can affect academic performance. That would be erroneous because it has only taken a 5% contribution. Then what about the remaining 95%? The remaining 95% that is not taken care of here, we usually call it stochastic error, which means there are 95% of other things that could influence academic performance which are not taken care of in this model. So that is why you're not going to use that model or generalize that model. But you can use it to explain that. It means that there is a likelihood that, not even likelihood, there are some other strong factors which are not considered, which your work has to continue to push forward to ensure that you look out for those factors. And that is what will lead us into that other one that will lead us to multiple regression. Here, I have only used simple linear regression to explain, but we're going to consider multiple linear regression where we're going to have many variables regressed against academic performance. You know, we have only used, we're going to have a number of other variables in this data set that want to test against academic performance. And at the end of the day as well, we'll see whether those variables that we want to regress in that our research question 3, they are also enough to speak for all the factors that can affect academic performance. And what is the contribution for all of those variables, each of those variables, to what extent, what is the quantum of their contribution to impacting academic performance? And that's what we want to do. So here now, if I want to bring out these, let me get to the major one, and then I will explain further. Now, when you are computing what do we call it? Regression. You must formulate a model that you are using to explain what you have done. So from here now, I'm only following this model to bring all my modules together. Now, normally you also decide, okay, SH ordinarily is representing a skill hour like this. You are expected to explain what each of those things stands for. Like I have done in my own PhD, part of my PhD thesis output. Like 1 is highest qualification of founder. My X2 is highest qualification of production manager. My X7 is prior work experience of marketing manager. My X13 is internet services. My X20 is science of employee. My X23 is cooperation. Checking whether there is cooperation between them or not. So the same thing is what you do here. You have to define. Your Y here is your dependent variable, which represents your academic performance. You're not going to be calling it dependent variable in your model. You have to explain it below. And so this Y represents academic performance, which the prosy, you must have defined what you use to capture the academic performance in your methodology. Okay, so, and then Y is equal to B naught. What is B naught? B naught stands for constant in that equation. It can be C. You remember our Y is equal to MC plus A or something like that. Y is equal to MX plus C. Yeah, something like that. MS plus C. Where, okay, let's go on this way. Let me explain it this way. Y is dependent variable, the left-hand side, is also equal to the right-hand side. So the right-hand side, the first thing here is your constant, which is represented by B naught in this case. It can be anything. It can be A naught. It can be A1. Anything of your choice. But just ensure that you define it as you go on. So you can see another B1 here, which is the coefficient of SH. SH is a short for, let's check our data and quickly tell me what SH is. Let me go to the data. Okay, let's go to the variable view. Study hours. Yes, let's say study hours. Can you see study hours? So the number of hours the candidate spent in studying, that's SH. So that's study hour. Okay, that's fine. Then the other one is RS, research skills. Good. ICT is the ICT usage. MI, I think, is motivation or something. If you check, you can confirm. Then EY, is not, I don't think it's motivation because that's so that you will not go. Monthly income is MI. Then EY is education in years. Fantastic. Education in years. So we have those models that we have regressed to get, we want to regress together. You can see that I painted some yellow. B1, B2, B3, B4, B5. All those ones, they are called coefficients of the variables. So B1 is the coefficient of SH. B2 is the coefficient of RS, which means the quantum of the contribution. All of those things are going to be in values at the end of the day. So B1 is the quantum of contribution of SH on Y. B2 is the quantum of contribution of the impact of RS on Y, and so on and so forth. So plus E here, this epsilon here, epsilon, it's talking about those factors that are not taken care of. And we call those ones stochastic error. They're not error, but we call them stochastic error. They're not error indeed, but they are variables that your model did not capture, which you can easily see the quantum by looking at the R squared. R squared will tell you the amount of variance, or the amount of variation of all these put together in Y. The amount of variation of Y, of all of this quantum in Y, it will tell you. That's what your R squared would indicate. So the remaining, the leftover over 100, is the stochastic error that we have not taken care of. So ordinarily, you cannot get 100%, but if you can have a certain threshold, it's good enough to go home with, to report, oh, wait a minute, this is what I have done. My model has only captured 70%, 56%, 65% of the variance of the variation in academic performance. And these are the variables that are responsible for all of that. So each of them represent this, and this. What am I saying? Now, we have done the output now. Okay, so this is the output now for, have I done for those variables? Yes, I've done for them. Oh, I've not done for the list of those variables. Okay, so this is what we have to do now. So this is the normality for that one-to-one that I said the other time for the academic performance. You can see that this won't follow a normal curve. There's no skewness. It does not skew whether to the left or to the right. So this is a perfect normal whatever. So I'm going to click here to go to regression. We want to regress linear regression. You click on linear regression. You can reset all of this. Reset here. Our dependent variable that we have agreed on is academic performance. I want to bring in, what are the variables we want to bring in? We want to bring in SH, which is SHRB. Study hours, you bring it here. The next one is RS. Thank you, RS. RS is what? Research skill. The next one is ICT and MI. ICT, MI is monthly income. And then EY, years of education. Okay, how many years the guy has spent in education? Fine. So you have those variables now you want to check with academic performance to see what they're going to have. So let's come back to our statistics here and pick what we want. We want the model fit, we want the estimates, R squared change. We don't want that for now. Let's say we want the collinearity diagnostics and W in Watson. These are some of the things we are going to use to check whether there is collinearity in those variables we have selected. When your collinearity diagnostic, I'm going to show us, we call it variation inflation factor. It will show as VIF. When it is more than 5, then variable. You have to check, this variable is likely to have caused multicollinearity. But once it is less than 5, then you are good to go. Some other authorities will tell you that you can still manage up to 10 VIF. If the VIF of that variable is still 10, you can still use it. But anything more than, when it is larger than 10, then it is chaos. So what collinearity diagnosis will do is to diagnose, to inspect that thing for you. We're going to see it. I'll just click on continue and I click on OK. So here comes our output. Here comes the overall output. Don't be scared with some of those outputs. I will explain to you one by one. So look at it here up to this point. So the major one is the model summary, which is telling us that the relationship between the predicted and the observed is 0.745, which shows very strong relationship, which shows what we are predicting, the value predicted and the value observed, they are almost at par, almost very close, which is very strong. One is good. It is encouraging. That's the R. But the R squared, if you look at it, when you multiply this one by R by 100, it's giving you 55.6. This is better than less than 5, that where we are coming from, when you only regress one variable. So it means a good number of those variables have actually been responsible and they have been taken care of here, which means the R squared here is 55.6%, which is still fine enough. But then it's still something is still ringing behind my head that it means that if this thing is not more than this, there's a likelihood that there are some other variables that we have not captured even here as we speak. But you still have to run what you have to run. So the adjusted R squared is to check. The adjusted R squared is also to see whether this is just by chance or not. And you can see that it's not far from the R squared, which means it is not by the R squared is not by chance. It actually happened that way. This R squared, adjusted R squared, is a confirmation for your R squared, which is what we have done. And then the standard error is about 5.3, and the Dublin-Watson figure is 2.1, which Dublin-Watson also has a threshold. You can Google it to say what is the acceptable Dublin-Watson threshold for any variable. You can do it from your end, and then you will see the rate. So this is the way all of these things during our own time as well. Nobody taught us. They will just give us the theory and you run with it. You also have to search for a number of things to argument some of these things I'm presenting to you. Okay, so the ANOVA also, that's the model summary. That's part of what you're going to be reporting. That's the model summary. And then the ANOVA is also showing us, I think I put it on our platform, how to report this as well. You will see there. You will see F, this is F here. When you are reporting this ANOVA for regression, you will see F is 5,994. You can see our 5 here, which is in the regression, which is the degree of freedom. The degree of freedom is your n minus 1, where your n is the total number of variables that you have considered. So the degree of freedom is n minus 1. Like I said, where your n is the number of variables. All the variables we put together, they are study hours, research skills, ICT usage, monthly income, education and years, and all of that. So normally it should be n minus 1. I don't know where it's giving us 5 here. How many did you consider? And it's showing 1, 2, 3, 4, 5 here. Okay, and I think including, yes, it's true, including dependent variables. So we have computed 6 variables. So that's 6 minus 1. That's where we're having this 5. But the 994, it is the sum of square and all of that SPSS has computed behind the scenes that we do not know. So when you are reporting, you will say F into 5,1994. F bracket open bracket close 5,1994 is equal to 248.622 or 0.62. That is your F. But ordinarily what it is telling us is once you have very strong F, very large F, it must, anything that is more than 5, let me tell you, more than 5, it will show significance. It's telling us that, and when you now look at this significance, you can see that this is less than 0.01, 0.05. So which shows that the model is reliable. The model is significant. That model, the regression model that we have generated, ANOVA is confirming to us that it is significant. But they want to see the level of significance. They want to have other information. That's where you're going to put the ANOVA value, which is F into open bracket 5,994 close bracket. It's there on the Telegram. I think I posted a sample. 5,994 is equal to 248.62. Once they see that, they will know. And then you now say our rho, which is our P, the significance, is less than, I think, 0.01. That's the way you're going to report it. That is the aspect. Now, the major contribution of those variables are what is listed here. You can see this one now. You can see on standardized coefficients. You can see the B value here. The corresponding standard error the standardized coefficient here, the t-value, the significant here, the collinearity statistics that we said that the system should output for us. If you look at the VIF here, there is none of those variables that are more than 5. This shows we are good to go, which we have apparently seen in the correlation that it has low relationship. None of those variables have more than 0.3 and above correlation, which is an indication that we are good to go running regression. The VIF, which is a short for variable or variation inflation factor, is also confirming that we are good to run regression analysis. Because if you run regression analysis with multicollinearity, then nobody will approve that regression for you. You will have succeeded in generating erroneous model. And this is the way to guide against all of that. Okay, that's fine. Most of the guys that are running this for you outside, they will not consider all of these things because they don't know it. So that's why I said it is better for you to have the understanding yourself and handle this thing by yourself. They didn't bring it from heaven. It is not rocket science. Okay, that's fine. So let me now talk about the interpretation of each of those. Now, the constant is 31.48 and the corresponding error is here. While we keep every other thing constant, keep them at 0. Use 0 to multiply study hours, 0 study hours, 0 research skills, 0 ICT, 0 monthly income, 0 education in years. The academic performance will be 31.48. The student will still get 31.48. That is, it's just like you have a, you remember this NEPA bill then that they normally give us. There is this fixed amount and variable amount, you know. So this is the constant is standing like the fixed amount, like the constant. So that is that. And if anything will change at all, it has a plus or minus 1.278 for the constant. Now, we have introduced study hours. Study hours has a proportion of 0. This is the B naught. Oh. This is for the corresponding value of the coefficient of study hours is now 0.34 when you approximate to 2 decimal places. So when you are writing your model again, you have to write this model again. You are going to be putting the figures. After you have, this is when you are just proposing the model that you have not tested. This is the way it's going to be. That's your equation 1. In your methodology. By the time you get to your, what do we call it, to your result, what you are going to have is different. So our B naught here is this guy, 31.49. Your B naught will be replaced with 31.49, 31.49. And your B1 here, which is the coefficient of SH, is now our 0.34. You come here and put 0.34. Don't worry, the plus is not addition. It's not addition. Don't worry, it's not addition at all. And then the B2, which is the coefficient of RX, is 0.28. Okay, I got 0.28 here. And the coefficient of ICT, 0.83. And the coefficient of B4, which is, of MI, which is our B4, it's, this is negative. This is about 2.20 times 10 raised to power minus 5, which is 0.0000000021222. That is it there. So which is very, very negligible. But then still have to write 0.0000025 or something. I mean 22. Let me check again. That's 22. Yeah, 22. 1, 2, 1, 2, 3. No, that'll be 1 0 more. So do you remember standard form? This is it here. If you escape in primary school, you come and meet it here again. So I hope I get it correctly. So this is 1, 2, 3, 4, 5. Yes, I'm correct. Correct. You can challenge me if I'm not. So that's what you're going to put there. Then for your EY, the coefficient of your EY is 0 negative. You can see negative here. This is negative 0.004. So you're going to put 0.04 and then change this value to negative, to minus. You change that value to minus. So that's your model. That's your model. That's your model. So this is the final output. But now, what is that interpretation? This is what is expected. This equation is what is expected in what do we call it? In your chapter 4. The other one is equation 1 is expected in your chapter 3 with all the explanations. Now, this is the output. Now, when you now have this, how do you then interpret it? I'm going to show us. I'm going to show us. If you want to look at the most significant, the one that contributed most, you will look at the T value. You look at the T value. Which one contributes most now? The one with the highest figure contributes most, apart from the constants. Answer that in the chat box. Once I have like 5 responses, I'm fine. Which one contributes more to academic performance? How do you know them? You look at the T value and look for, you can rate them by that figure. I'm waiting for your response. So which one has contributed more or most among the variables? You use that by tracing the T value. Thank you. Two people have, okay, somebody said research skills. Then another person said research. Okay, everyone said research skills. So let's see. Research skills, fantastic. It has 12.94. You know, it has the most contribution. Which one contributed the least? The least now. The least. The list now. The list. Any response I see now, I want the list. Good, good, good. Education in years contributed the least. Can you see that? Because it is only 0.5 and it's a negative value. Now you can see also here the significance level. Every one of them, they are less than 0.05, also less than 0.01. Except which one? Except which one? Which means those ones that are less than 0.05, they are significant. Anyone that is not less than 0.05 is not significant. So which one is not significant here? Which variable is not significant by that? Fantastic. Education in years. Education in years is not significant. So you will inspect all of this. Is the way to interpret it. It's as simple as that. Then, when you now want to report your regression model, further, the main thing that you should speak to is what I have not mentioned. You will now say that if you pick on these study hours, you look at this 0.0339. What this means is this. 1 unit increase in study hours, that's the way to report it though. 1 unit increase in study hours will increase the academic performance by 0.34. Do you get that? I repeat, 1 unit increase in study hours, if the guy who had one more hour to study, that student shall have added or impacted the academic performance by 0.34 units. Do you understand that? Now, if you want to also do the same for research skill, if the research skill is increased by 1 unit, it shall have increased the academic performance by 0.28. Then if the ICT usage is also increased by 1 unit, it will also increase the academic performance by 0.82. Then let's look at income. If the monthly income is increased by 1 unit, it will impact the academic performance by this negligible amount. That negligible amount may be big when you translate it to, because we have capital monthly income in naira, is that not? So what this is saying is, if you increase if your monthly income is increased by 1 naira, that is when it will have this very, very, very small amount of impact on academic performance. But when you multiply this one by 10,000, if your monthly income is increased by 10,000, then it will increase the academic performance. You will now use 10,000 to multiply this value. So when you use 10,000 to multiply value, that means it will give us something in the range of how much now? How many zeros do we have? 10,000, that's 4 zeros. So we'll have removed 4 zeros. Yeah, that's significant. Or if you say even 100,000, you shall have increased the academic performance by that quantum. So that's what we're saying. So if you now pick one of them, that monthly income, if 1 unit of monthly income is added, then it will impact the academic performance by this much. Yet, this is significant. If you pick study hours, 1 unit increase in study hours will increase the academic performance by 0.34. And this is significant at the level of 0.01. That's what you should write. That's the way it is done. Do you get? Now, if you look at the last one here, You will say education in years. Education in years. If education in years is increased by one unit, which means maybe 1 year, then it has the propensity to reduce because it's negative, it's not increased now, to reduce the academic performance by 0.004 units. What we look at, what is the meaning of this? Does it mean that if I have a PhD, because if I have a PhD, my academic performance will even be lower than having a first degree or something like that? So it will be, but you will say at the end of the day that this statement is not significant. It's not significant. So that way, you will not reckon with education in years because you already reported it. Not that you will not reckon, you have to report it. It has negative impact, but not significant. But not significant. So that is your regression. And that's all you have to do. I'm going to quickly explain in the next 3 minutes or so how you are going to do the next one. Now, don't forget responding to this question. The fourth research question says, does motivation moderate the relationship between study hours and academic performance? Does motivation moderate the relationship between study hours and academic? These are the questions we ask under the topic of our thesis, which is like the research question of maybe like the objectives that we have set under that. So I'm sure some of you, your research is like this. So you've already seen how to go about your work. So it's asking question, does motivation moderate the relationship between study hours and academic performance? So what you have to do is to do moderation regression. And how do we do that? You have to do your first variable you want to consider, which is your, what do we call it? We're talking about study hours. You want to consider study hours and academic performance as a dependent variable. And we're also considering motivation. So it means we are considering 3 variables here. 1 as dependent variable and 2 independent variables. So you have to talk about the first one, use the second one, motivation, and then the third one is not going to be the interrelationship between that motivation and what? And your study hours. So in that case, you have to cross them. What do I mean? You have to multiply it, and then you specify that as well in your model. So I've explained what you have to do when it has to do with the motivation, when it has to do with the moderation regression. Okay, so you just have to multiply that together, and you'll be like, how do I do this? Where will I get this variable? So, we already have a variable. We can easily pick variable for SH, which is our study hours. We also have a variable for our M, which is our motivation, but we don't have a variable for SH times M. So what you will just do is you go back to SPSS and do the multiplication of those variables. So that way, you have to generate another variable. So I'm going to show us. You can see it's very, very interesting. It's very, very interesting. Very, very interesting. So you come here to here and click on transform. What you want to do, you want to transform. Transformation is what you want to do. Okay, transform, then let's say compute variable. We want to compute the variable. So what do we want to compute? We want to multiply what by what? We want to multiply study hours by motivation. Okay, so you will say this is our output variable. Study hours multiplied by wait a minute again. By M, motivation. Let's say this is the name of our new variable. That's the target variable. So we'll now pick study hours, which is study hours here. You output it to this place. Here you click on multiplication. Star represent multiplication. Multiply by motivation. You click motivation here and you drop it. That is it. You have multiplied it. Or you just need to just say okay, and you are good to go. You'll be like, where is this thing now? So you now go to your data view and check the last column. It must have been inserted. It must have been generated and inserted. And I'm going to show us. Can you see? Can you see it here? It's already inserted and generated. So by the time you now want to combine those variables together, don't forget we are combining how many variables? We are combining study hours, motivation, as well as the multiplication of that against academic performance to represent what you want to do. So you come in here again and say regression again now. Let us clear what we used to have there. You clear that, you can reset. Our dependent variable is still academic performance and other variables. Now you can see this guy now, what to show Joy. But this is the third one. This is the third one. We have done that of academic performance now as a dependent variable. I will now pick the other one, which is study hours, SH. We'll bring it here as the independent now. Motivation, where's motivation again now? Motivation is here. I'll bring it here. And then SH, the cross, this is the multiplication. This is the, what do you call this? This is the multiplication, the two variables that will multiply together. That's what you have to do. Then don't forget again, you just click on your this and then select whichever model you want to output. Whichever one you want to output, and then you just click OK. You just click OK. Just click OK. And that is it. Let's see what you're going to have. So whatever you have it there. So you just have that and you're good to go. So you just have that. So can you begin to inspect it? You can see that. See the R squared, so I want you to inspect it and you'll be prepared to speak to this. So how to interpret this. I'm waiting for whoever is ready. So let me give you 1 minute to inspect it, and then you must have contribution to this model. Tell me how to explain it. So who is ready? Who is ready? You can see now, like I said, you can see the F now. This is the ANOVA. We can see the general model as well. The R, talking about, you know what I'm talking about. You can see the R squared, what this represents. You can also see the degree of freedom here, which is something, and then F. Also look at significance. And then look at the contributions here. And then, what can you now say about what we are predicting? What we want to talk about, which is about this asking question about, does motivation moderate the relationship between study hours and academic performance? So from this model, will you say yes or no? Good. That's the question. That's the question. Me, I finished my class. Over to you now. I'm pushing it to you. Does motivation moderate the relationship between study hours and academic performance by the output that we have here? What do you have to say?
I'll say no, sir, because we have a strong. Sir?
Why? Why would you say no?
No. Okay, sir. I think I'm misinterpreting, but the both on their own study hours and motivation is P less than 0.00. P is less than 0.05. That's that they are significant. But the SH below is 0.944, which means it is a strong correlation. And in my interpretation, I'm thinking that is study.
You don't go. That's not correlation, is not significant. So you got the first explanation, but the second one you didn't get it. Okay, so that's why I'm truncating, so that before you begin to kandawa our head. Who wants to bail out?
Okay.
Eh? The first two on their own, standing alone with others, they are significant. That's correct. But the last one, which is the cross, the moderation between those two guys is not significant. That's correct. But what about the contribution? You did not speak about the contribution in terms of the B value, and then the contribution in terms of the T value. No, now. Which one has the most impact?
Is it the F?
The most contribution. We are talking about these coefficients now. We are talking about these coefficients.
Coefficients. It seems motivation has 4.218. The T value is 4.218. So one can say it as the highest there, sir.
Fantastic. That's correct.
Am I on the way, sir?
You are correct.
And then we have the significance, which is 0, 0, 0. That's why I'm confused. There's nothing then significant. 0, 0.
The significance, we already told you. The value must be less than 0.05 before you can say it is significant.
Okay.
So in this case, it is true.
Okay, sir. Thank you, sir.
But look at that value 0.944, that is more than 0.05 because it's not less than 0.05.
Okay, sir. Okay.
That's why it's not significant.
Okay, sir.
Then there's one other thing that somebody else may need to talk about, the contribution. Like I was talking about, 1 unit increase in something will lead to another thing in somewhere else with these values.
It means that
Who is speaking? Your name?
Dorcas Bakari.
Okay.
So the content is 48.5. So 1 unit increase in study hours will lead to an increase of academic performance.
No. You are talking about 48.47. That's the constant. The constant, I explained that when study hours is 0, when motivation is 0, when SH cross M is 0, then the academic performance will remain at 48.48. Do you get that? Is the meaning of the constant if you want to speak about the constant. But go to study hours, motivation, and SH&M. So yeah,
so
continue.
if study hours increase by one unit, then academic performance will increase by 0.579.
Come again.
I said if the study hour increases by 1 unit, then academic performance will increase by 0.579. And if same with motivation, if it increases by 1 unit, then academic performance would increase by 0.183.
Good.
Then there is no significance for SH. No, it's significant.
The two of them are significant too. Go and look at the example I posted on the Telegram. That's the way I expect you to report it too. You get that? What about the SH&M? What will you say about that?
There is no increase.
If you increase SH&M by 1 million units, there will be zero increase on academic performance, which means what? It does not have impact on academic performance. But this is not significant. Do you get? He's saying, does motivation moderate the relationship between study hours? And it does not moderate the relationship. Motivation does not moderate the relationship between study hours and academic performance. Do you get that? That's what this is telling us. So using motivation now as a mediating variable. That's what that is saying. So the remaining, you are going to do it on your own and prepare a report and submit on. This is the fifth one. The fifth one is even very simple. You just have to create like 2 models. I've already explained it. The first model will have that. The second model, you will add these are created that. The addition will now generate the second model. You first of all create the first one, and then you get your answer and your output, everything. You report that. Then you now create a second model by adding this to the existing. And then you have to compare the 2 models, compare the R squared, compare everything. Is there any change when from, is there any change in the R squared and all of that? These are some of the things that I should speak to. It's very simple. So you enter control variables, block 1, block 2, enter academic predictors. Where they want you to do this together. You can do it together, but let me show you where the block is in your regression. Let me quickly show you so that you won't say, we can't find it. So analyze. Come to your regression here. It's a linear regression. Put all the variables. The first part is here. This is block 1 of 1. Once you are ready with the next one, you just click next. And this one will disappear. That is the second block. You will now put the additions here and then run. That way, it will generate 2 separate models for you. Okay, that is that. Any last question so that I can release you for the day? Don't forget my assignments to be submitted on or before Wednesday.
Okay, can you quickly do the last explanation, the one you did now? I can't get it very well.
You come to analyze, you go to regression like we used to do, click linear regression, and then you normally know that you have your dependent variable here, you have that old other first variable here. That's block 1. You are now asked to add additional variables, is that not? This is the first set of variables that you have to consider. After putting all the variables here first, you will now next to click the addition as listed here. You will now put the addition here, this one, come here, this one, come here. I don't know whether those ones, but I'm just picking them arbitrarily. And then you just click OK. And that's all. It will generate 2 standard models for you, and you are good to go. So this is where we're going to stop the class today.
Thank you, sir.
Welcome.
Thank you, sir. God bless you, sir.
You're welcome.
I don't know if
sir,
if I will have the opportunity to say this, sir, before you go.
Oh yeah.
Thank you, sir. Yes, sir. Thank you, sir. We really appreciate you, sir.
When is the examination?